This is example 3 from chapter 2, looking at an ungrouped frequency distribution. All right, the example is the following data represent the number of pairs of sneakers owned by 15 people. Build a frequency distribution, draw the frequency polygon in ogive. So we're going to look at how to build a frequency distribution when we have ungrouped quantitative data, and we'll look at 2 new graphs here. All right, so we have our data here with 15 items, and with the categorical frequency distribution, we had a table with 2 columns. In this case, we're going to have a table with 3 columns. The first 2 columns are going to be very similar to what we had done before. We're going to have the categories in the first column. In this case, those categories are going to be numeric, though. The second column will be frequency, and the new third column will be CF, or cumulative frequency. And we'll talk about that as we start filling in the data. Now, one difference between the categorical and the ungrouped is in listing of the classes. In the categorical, if you think back to our motorcycle example, there were no Hondas in that data. And we didn't list Honda on the page, you know, as one of the classes, and that was fine. One of the things you have to do here is when you are listing classes for your ungrouped, you need to span the entire range. So in this case, if you look through the data, the lowest value you'll see is a 0, and the highest value is a 5. So we need to go from 0 to 5. Now, even if a number doesn't appear anywhere in the data, if it's between 0 and 5, it needs to be there. And you'll see why whenever we go to graph these, you want each number represented, because if you, again, looking back at chapter 1, this is an interval scale. Each class is a specific interval above the other one, the previous one. So we don't want to be skipping things there. We don't want the classes to go 0, 1, 2, 4, 5. That would potentially be confusing. So even if there hadn't been any 3s in this data, we still would need to list 3 as a class there. The frequency would just be 0 if that was appropriate. All right, so we listed our classes. Again, it's slightly different than the way we did it for the categorical. We'll go through and get our frequencies the same way, though. You can either go through, make your tick marks, or you can go through and say, all right, we have just 1 0. We have 5 1s, 1 there, 3, 4, and 5, and so on down through that. We have 5 2s, 1, 2, 3, 4, and 5. 2 3s, 1 4, 1 5. Now, if we total that column, we get 15, which is how many pieces of data we have, so that's a good thing. The cumulative frequency column is the total frequency up to and including that class. So for the first class, the lowest class here, the cumulative frequency is always just equal to the frequency. For the second class, it's the frequency of the first class and the second class, so 1 plus 5. For the third class, it's the frequency for the first 3, so 1 plus 5 plus 5 is 11. Fourth class, 1 plus 5 plus 5 plus 2 is 13, and so on. And what you'll notice is essentially you have 1 plus 5 is 6, 6 plus 5 is 11, 11 plus 2 is 13, 13 and 1 is 14, 14 plus 1 is 15. So there's the ungrouped frequency distribution. Again, the only difference is you added the cumulative frequency column, and now keep in mind, don't throw that on a categorical and say, well, I'll just throw it in just in case. That cumulative frequency only has meaning if you have at least ordinal data. And the best real-world example I can think of for cumulative frequency to try to explain it would be if you have a company that you're tracking monthly sales and you have year-to-date sales. So in January, it's just January. February, it's January plus February. And so on until you get to December, it's all 12 months. That's essentially what cumulative frequency works out to. All right, so that's the first difference. The second difference is if you have any missing classes, you have classes here that don't have data, you need to list those. Now, we didn't list 6 here, that's okay, because 5 was our highest, but if any of the intermediate classes hadn't been there, we'd still need to list that class. Now, to build the frequency polygon, what you're going to see is you use the same, essentially the same axes as you had in the histogram. You'll have your classes along the horizontal, and you'll have frequency on the vertical. Now, the difference is, in this case, instead of doing a vertical bar chart, it's a line chart. So you look, the first class, 0 sneakers, is at 1, then it goes to 5, 5, 2, 1, and 1, and you get to play connect the dots. Now, in the book, they always show both sides would be closed down to the axis on this. As you see, Excel by default does not do that. I don't know if there is a way with a lot of work to do that or not. And realistically, it doesn't make any difference in the information you're conveying. So I wouldn't get too tangled up in worrying about closing the left and right sides. If we were to lay the bar chart, the histogram over top of this, you'd have a bar. The bars would just be the heights right here at these points. And again, as I mentioned last time, label your axes. You know, when somebody looks at your graph, they want to know what those axes are. Now, we have another new graph, and this is the ogive, or you'll sometimes hear it called a cumulative frequency graph. Nice thing about that is it's a tip-off as to what you're graphing. The cumulative frequency graph, or ogive, is another line graph. In this case, you're still going to have your classes along the horizontal, but in this case, your vertical will be cumulative frequency. So, back to our data, we started with 1, went up to 6, then 11, 13, 14, and 15. Now again, in a book, here they had always shown the left side closed, but they left the right side open. Again, Excel, by default, does not close either side, and that doesn't make a big difference in terms of what the value of the chart. Again, though, I would point out, label your axes. In this case, you look at it, okay, is this frequency or cumulative frequency? You want to make it obvious that it's cumulative frequency. So, one other thing the book talks about with frequency polygons, they talk about the midpoint of the class. If you are going to go with a single number, and then this has more reference when we get to example 5, we'll talk about more, it talks about the midpoint, so don't get too tangled up in that. Stay tuned for number 5.